All right, so we are ready to go. Welcome everyone to my talk on strawberry fields forever, digesting the landscape of large language models and how to successfully adopt them in regulated contexts. My name is Devin Pastoor. I'm the Chief Technology and Product Officer at A2AI. We're a consulting group that does a blend of scientific and technology work. And the examples that underpin much of this talk are driven by a combination of our own internal R&D efforts to support our scientists, as well as interactions with client teams. And so large language models are a very hot topic. There has been an explosion of activity around LLMs and products developed on top of them over the last couple of years. And one of the consistent themes when anyone first interacts with these LLMs is we talk about a wow factor. And this wow factor is something that is pretty easy to find, especially if you're doing things like code generation. In this case, for example, we can ask, create a plot for concentration time with ggplot2, and we're going to get this response that is kind of well formulated, includes formatted code, some sample data, and even an explanation. And this is quite amazing to virtually anyone that kind of tries this. And of course, questions can go beyond just code generation. It has knowledge and capabilities across a broad spectrum of topics that it has encountered when it was getting trained. And because of this generalizable capability set, companies are recognizing there is a range of possible applications, and they're kind of wrestling where and how to best take advantage of what solutions might look like. There's medical writing, there's code generations, there's quality control, there's synthetic data generation, lots of options, but where to start? And so today's talk is going to be about exploring some of the concepts that underpin the strengths and limitations of LLMs, to show the components that make up the solutions built around these LLMs, and to highlight some tips for success if you're looking to start to use these large language models in your organization. So let's dive in. Large language models are trained on huge amounts of content: books, articles, websites, publications, and much more. The training, though, is not necessarily about memorization of all of this information in the way that humans can memorize facts, or some attempt to kind of store and consolidate this information into a database for later retrieval. Instead, training is about learning patterns, relationships, and other associations between words, phrases, and ideas that the LLM encounters while it's being trained. And as such, the model doesn't actually retain specific data directly. Instead, when you ask it a question, it constructs a response based on the statistical patterns it has learned during its training. So when you ask it something, it answers actually by predicting a response based on how similar conversations were structured in its training data. Now, one area that might surprise you with this, if you've been interacting with these LLM products like ChatGPT, is that the LLMs themselves are stateless, meaning that each incoming query is processed independently of all prior interactions. The only thing that exists is that current input, nothing else. And yet, when we start to use services like ChatGPT, we immediately are drawn to the conversational capabilities as a core part of this experience. We don't just ask it a single question. We want something that we can review and iterate our way to success. And so, for example, with our previous plot question, we might actually then say, well, let's update the plot to connect the lines by subject. Or now use an explicit column name for the x-axis, TAD, and remove the title. So we take advantage of these prior interactions. But this is not actually the LLM itself, at least by itself. It's also additional engineering work built on top of the LLM that's doing things like connecting that chat history over multiple question and answer cycles. And so here's where we get to our first tip for success. Recognize which parts of desired solutions that you might have seen from demos or otherwise, and which part is the LLM, and which part must be built on top, especially if you're going to be building something yourself. Now, thankfully, there is an ecosystem of tools blossoming to make this much more approachable. And so before we go too much further into what we have at our disposal, some of these tools and how we can glue them all together, I also do want to show a bit of a counterpoint where this seemingly limitless capability can go wrong. And so let's ask another information retrieval style query. What STDM domains store concentration data? Give me some examples of that data. And on the surface, this response looks excellent. But if you've interacted with LLM-based solutions for a long period of time, your spidey senses may be tingling. And in fact, if we do actually go out to the spec itself and start to compare it carefully, we see some things are missing. And so using that conversational capability, we might try to kind of interrogate the LLM's response and see if we can get it to kind of spit out some additional information for us. So we might say, which of the fields are required? Are there optional fields you didn't include? What are they? And what you can see here from this snippet of a response is actually a number of problems start to emerge. In this case, it actually has improperly reconciled what it had previously responded with, as well as later on in this kind of truncated response, it actually gave some kind of factually incorrect answers. And so this type of experience, you can go from that absolute wow factor to this kind of trough of disillusionment very rapidly. And these challenges are not necessarily solely tied to these broad, open-ended, kind of squishier questions. In fact, let's look at another example that inspired the name of this talk. If we want to ask how many R's are in the word strawberry, this seems like a simple kind of count the letters query, but ChatGPT responds, well, there's 2 R's. Okay, let's actually ask it to do some work for us. Can you break it down by letter? And unfortunately, it also fails originally there. Now, if we keep actually prompting with it, are we really sure, give it some instructions, it actually can get to that correct answer of 3. But this is a far cry from that original kind of wow factor. This is something that can do anything. And so how do we reconcile the breadth of capabilities against the risk that these responses can come in with the same degree of confidence, whether they are correct, partially correct, or full of these hallucinations? And so our second success tip is tread carefully when you're exploring these LLMs. Pick a constrained space where the outcomes and value to your organization can be assessed easily and that AI fact-checked. It is absolutely possible to do amazing things with these LLMs, but you need to do so carefully. So if we're going to be doing that, if we want to dip our toes into the LLM waters, let's actually unpack some of these building blocks that would allow us to build these full-featured solutions. And so at a high level, what we need to do is we need to take a user's query, we need some prompt, and potentially some additional contextual information, an LLM itself, of which kind of the ChatGPT, OpenAI LLMs are only one of many possibilities. And we need to write some application code to glue all of this together, orchestrate it, and overall shape the experience that we want to provide to our end users. So let's break each one of these things down. The prompt is our wrapping information used to supplement the user's query with some additional consistent contextual information that we might want to provide, as well as guidance to instruct the LLM on how to respond. Now, we need to keep in mind again that when we interact with the LLM, it is stateless, right? We don't have any sort of history or something that the LLM is aware of. That is something that we need to take care of, and the prompt is one of the areas that we can do that. And so if we come back to our original query that was used solely with ChatGPT, and instead now have our A2AI code chat that includes a prompt with some additional information around our conventional preferences, some organization-specific detail, we can get a refined response. And in fact, we do see almost identical responses between the two, but we can see our guidance at play, not to tell it to install packages, to prefer tibbles to data frames, and to use an internal package that's not publicly available and therefore was not public, the LLM itself would not be aware of that in its training information. Now, this is only a small sampling of what prompting can enable you to do. Prompting can also help you do things like control the output format if you want actual structured data like tables or JSON. It can tell the model to adjust the response based on the query context, or even to think. And there's an entire field of prompt engineering emerging to figure out how to best use prompts. In fact, one of my favorite prompting examples was, instead of just including the phrase, write out all the code, to get the model to not truncate code outputs when it was responding, instead adapting that prompt to say, write all the code, I do not have fingers, and I need you to write all the code for me, actually improved the likelihood of getting full code back. And so here's our success tip 3. Start simple. Using prompting techniques to adjust output can be a great entry point for experimentation. And in fact, prompting is something you can also explore even with these available solutions like ChatGPT, where you can essentially use that prompt itself while you wrap your own query to kind of experiment with how the information fed into the LLM can change its output. Now, on top of why prompting can be an excellent starting point due to its kind of technical ease, this is also something that can give you an opportunity to quickly prototype something and start to test the organization's appetite and maybe some operational hurdles associated with getting access to LLMs in general. And this is something that some of the other speakers have already spoken to as something that can be non-trivial in these enterprise environments. Now, with the prompt, with this thing that we can kind of wrap these user queries in and kind of pack some guidance and some information on every query, we can only get so far when it comes to all the information that we might want to include, especially in contexts like medical writing, where we might have a much broader amount of data that we might start from. And so to add to such context, we want to include that information for the LLM to synthesize, but there are limitations. Some of those limitations are technical, some of them are operational or kind of cost limitations, but realistically, it's never going to be feasible to pack all the information you have into each one of these queries. And so how do you do that? How do we get this information in there successfully? To talk about this, let's use a kind of a challenge and an example that we ourselves explored that's reasonably popular as people kind of try this out. And that was to come up with this code chat example that enables us to kind of absorb a broader set of organizational questions that are guided by existing data. In our case, data that we had in our knowledge base. And so for this, we chose one of our test questions as, how do I install our packages from GitHub? Now, on top of this being kind of a question that we want to be able to answer with our knowledge base, this one is particularly interesting because it's something that does exist kind of publicly, so to speak. And in fact, when you actually query ChatGPT, you get a well-formulated and technically correct response. But in our case, this response was incorrect and not aligned with our guidance. And so what we wanted to do is take articles like this that we had internally and be able to provide them to the LLM so people can kind of ask questions in natural language and get these types of helpful responses back. So to do this brings the next concept that you might have heard the term for, called RAG, or Retrieval Augmented Generation. So with RAG, how this works is that you have some supplemental information that you can kind of extract bits of. You have to do some kind of chunking and other work to get it into generally a vector database. But once you have all of this information kind of encoded in there, there are techniques that you can then use based on the user's query to kind of figure out what is the most relevant data to provide the model and to combine that with your other kind of wrapping prompt information all together to get that interaction with the LLM and hopefully a helpful response. And so in our case, by putting all of these things together, we built a Shiny for Python app that we called Chat Docs, and we were able to reasonably quickly prototype the ability to actually synthesize a lot of our knowledge-based data in a way that people could ask questions and get answers in natural language. Now, one of the other things that I want to call out in the screenshot is what you can see on the left is the information kind of supplemented with our internal knowledge. On the right is just the generic ChatGPT response. And this was, again, something that as you're kind of starting to explore the waters is something that I highly encourage, building some of these kind of developer-centric applications that allow you to expose different information or try different things in ways that you can really start to institutionally understand how all of these pieces fit together. And as you change pieces, how it's going to ultimately impact the user experience. And so in this case, we are able to kind of put these responses side by side so we can very rapidly compare and contrast. Now for us, the kind of example for knowledge-based information that was kind of already textual information all in Confluence was reasonably approachable. But one of the biggest challenges we've seen when interacting with groups that are interested in developing such solutions around LLMs is when they actually take a hard look at what they're hoping the large language model will kind of help them enable across the organization, realizing that there are still a lot of data silos, and these silos may prohibit the ability to actually develop an application based on how things kind of are today to actually get the type of outcomes you're hoping for. And so kind of thematically consistent with some of the other success points, just again, keep in mind what you're trying to do and what data you might need. And before you go building too much technically, scope out if this is something that's even feasible, given some of the constraints that you're operating with at the moment. Now, this brings us to the last component of our application, which is the application itself. And in some ways, this is the heart of the overall experience that's ultimately going to tie together the components that we've just talked about. The application itself enables you to consider how to address users' queries, how to kind of glue together your prompt, how you might enrich the data, and ultimately things like which LLM or LLMs you might actually interact with in order to synthesize your response and get it back to users. And this is something that realistically is going to be very different, kind of solution by solution, product by product. And so you can do a lot with very simple things like just adjusting the prompt. But I do want to call out that these can get very complicated. And so especially when you're looking at some of the public-facing AI applications that are developed and productized by companies, there can be a lot going on behind the scenes. For example, a more complicated application to develop actually looks more something like this, where from that initial user query, you might do some upfront classification that has nothing necessarily to do with LLMs that can be very rapid. It can use that to actually figure out the intent of the user's query and then start working through kind of conditional branches of logic to do things like enrich with different types of data, potentially interact with one or many different LLMs based on how the kind of pros and cons and strengths and weaknesses of the LLMs, and ultimately combine all of that together to get that final output for the user. And so not that all applications need to look like this, but do recognize that these things can become very complicated depending on your objectives and your aspirations for the solutions within your organization. And so our final success tip, the talk, plan for a level of engineering and data curation and operating complexity to align with the sophistication and precision of the solution you're looking to provide. You know, if there is one takeaway here, we are not yet living in a world with an AI easy button solution. People are looking for some kind of, I can have some inputs, there's some AI black magic, and then poof, I have some organizational value that comes out the other end. But realistically, just like any traditional product, we need to be realistic around how all of the pieces, both technically and operationally and organizationally, fit together to actually approach some of these solutions. In my mind, this is an achievable goal. AI is here to stay. However, we have to kind of tackle this, realizing what we're in for and making sure that we're setting the appropriate expectation. Now, I know this was a very rapid fire talk that covered a lot of things, and yet I still had a ton of elements that go into building these applications that we didn't get to touch upon. But hopefully, armed with this information, and if you are somewhat new to what it means, like what it is to interact with these LLMs, this kind of talk was helpful for you, and you'll be positioned to better consider how to navigate the hurdles that you might face and have kind of gotten a tease of some of the techniques that you can apply when trying to actually integrate these LLMs into your organization. So let's remember, don't boil the ocean. Pick those constrained spaces where you can assess how well your solution is working, particularly compared to other options. Train people on the limitations and the caveats for successful use. Give everyone those spidey senses to make sure they understand what types of outputs that they're getting and how to interpret them. Consider, do you even need AI in the first place? Are there other opportunities to either use alongside AI or completely replace AI with investment in templates or training or other patterns that can still get you to the same organizational objective that you were hoping for? And if you go down that path, make sure you're assessing your data location, accessibility needs, and quality control when scoping potential AI initiatives. Finally, expect variable data and software engineering work across these applications. It's unlikely you're going to be able to kind of blueprint the same patterns across all sorts of different projects that you work on here. But by being ready and using some of those kind of common themes, you can definitely set yourself up for success. So with that, enjoy the rest of the conference. Thank you so much for listening. I will be sticking around to answer questions in the chat a little bit longer, and we'll also be available at the Hangout. So thank you all. I will stop my share.